Question 3. We are trying to integrate 0 to t and e to the s sine t minus s ds. So here t we can t is a fixed constant. Okay, just a small remark. So we do this question by integral by part. We will take u dv to the following. Let u is sine t minus s, and dv is e to the s ds. Why we take this? Because we can integrate e to the s, and so this implies du is equal to the derivative of sine is cosine, and the derivative of t minus s is minus 1. So we get minus cosine t minus s ds. So v is e to the s. Okay, so integrate by part tell us I, which is our integration, is uv, which is e to the s sine t minus s. And don't forget, we are integrating from 0 to t, so we take value from 0 to t. And minus integration of v du. So v du is e to the s times minus cosine t minus s ds. And the minus we can make it to positive. Okay, and we call this is equation 1. Okay. So we will do integrate by part again for this part. So let's say this is I1. So we let u equal to cosine t minus s, and again dv equal to e to the s ds. That implies du is the derivative of cosine is minus sine, but again we derive inside, which gives us minus 1, so we get sine t minus s ds. Integration of v is e to the s. So integration by part I1, which is this one, is equal to u times v, which is cosine t minus s times e to the s. Okay, so here is 0 to t. Okay, so we take value at 0 to t minus v du, which is e s sine t minus s ds. And this is our I. And we call this equation 2. Okay, so we put equation 1 and equation 2 together. How will we get? We will get so put 1 and 2. We'll have I equal to e to the s sine t minus s 0 to t plus I1, which is cosine t minus s 0 to t minus I. So we move the I from right hand side to the left hand side, we get 2I. So we have two I equal to here that's e to the s sine s minus t plus e to the s cosine s minus t from 0 to t. So that means I is e to the s sine s minus t plus e to the s cosine s minus t from 0 to t.